Hello guys, let's answer one of your fundamental questions that you might have right now. And that question is, why are we doing Java? Why Java? Especially if you looked at your course sequence and in the end results of learning those three mobile categories is you're going to be learning three major languages, right? You're going to be learning Swift. This is going to enable you to make iOS development. Let me make that iOS development. So for iPhones and iPads and anything Apple related. There's another language which you're going to be utilizing. It's called Kotlin. This is one of my favorite languages, one of my favorites. This one is going to enable you to create Android applications. And again, both of these are native to the hardware. And also Kotlin, you could use it for other things, not only Android, you could utilize it for app development, web development, etc., etc. And one last thing you're going to be doing is the web direction for mobile. All right, so this, I'm not sure what they have decided at the end, what they're going to utilize for this, so I'm not going to specify anything and have you misguided. But anyway, and in all three things, this web is not going to be Java, that's for sure. And all these three things, there is no Java included. But yet again, inside are one of probably the most important course inside OOP, Object-Oriented Programming. This is a paradigm, we'll talk about that later. We're going to be utilizing Java. Now, for one, I've not been the one who decided Java, but we are going to utilize it, and there's a lot of benefits that we could get from this. Well, the biggest benefit is, well, if you don't go mobile, you're going to go into something else. The biggest job market right now is inside Java. So it's a lot of job market. So it's going to be useful for you to get a job, easy for you to get a job because you know Java. Most of the times you're going to go for other languages, but it doesn't really matter because you know OOP. So let's say if you go in Swift or Kotlin, they're still using the OOP paradigm. And this is important to learn it, understand it, and master it. The language syntax shouldn't matter so much. So it's minimal, the language syntax. So going from Java to Swift and Kotlin is going to be a bit different because they're a bit more, let's say, more advanced, more this day and age. But going from there to there is still going to be easy because you understand fully OOP and how programming languages work. It should still function correctly. Java is also the same as like C# and a lot of other languages, right? In my opinion, I don't really like Java, but because of the way the world is, you're forced into it, I'm forced into it, so forth, so on. Like I find C# a much cleaner language. But anyway, let's moving on. Now, Java does give you some functionalities, features, something specified, like you could see this thing. I thought it was an interesting picture. I'm not really going to go through all of these things, but we could talk about some of these things. Let me just change my color here. So the first thing we want to talk about is this number one here. It's an object-oriented paradigm. This is called a paradigm. It's a way that these things work, or a type of way of manipulating files, or let's say not of manipulating files, but of working. Okay, and in Java is primarily a object-oriented paradigm. And we'll come to this. This is what we're going to be learning today, in this course. However, it does partially support other types of paradigm, such as generic programming, concurrent programming, functional programming, and a lot of other ones. Okay, so in the end, just make sure you understand OOP, and we're going to start learning others depending how far we get, how advanced we get. Let's see what else it has. Simple. Simple, it just means it's simple and clear syntax. It's straightforward of what it's going to do by what's written. So if the sky is blue, do something, right? The code is going to be readable. It's going to be a lot of English. So if you have difficulties with English, you're going to have a bit of problem. But it's going to be simple syntax. So here it's really syntax we're talking about. So simple things to say, and it's straightforward to what it says. Secured, we're going to skip that. Platform independent. What this basically means is if you write your code, you're only going to write it once for all different systems. So let's say over here, if we look, we have iOS. We need to do Swift to do iOS development. Here we need to do Kotlin to do Android development. And we could also do this web, which would build for both iOS and Android, because in the end, it's just a web. It's a website, right? Now, these are pretty specific to that architecture, to that platform. In the case of Java, you'll write one code, and it's going to be able to run on iOS. It's going to be able to run on Windows computers, etc., etc., until they install the Java VVM. Okay, so until they install the JVM, Java Virtual Machine, their code will work on all those systems without changing a single line. Well, you're going to say, well, web does the same thing. Well, web doesn't fully do the same thing. Web, based on their, let's say, their screen size, based on their pixel density, etc., you'll need to change the code to match that specific part. Anyway, this platform independence, I think it's a big sales pitch. It's not really platform independent. If you don't have this installed, it doesn't even work. And even then, it's like limited and blah, blah, blah. But it's a big feature of Java comparatively, let's say, to C#. Again, you'll need to install their stuff. Then it should still work. To be honest, this is not a feature anymore. So I'm just going to go and put this X on it. We could skip the robust. Portable is the same thing, right? If you have it installed, it doesn't matter where you go. Architecture neutral, we're not going to talk about it. This we'll talk about later, not yet. Some other stuff we're going to talk about for now is it has something called a garbage collector, which cleans the memory after itself, comparatively to C and C++, which you have to do manually. And that's a pain. We're not going to talk about that too much. One last thing I would like to talk to you about why Java is good. It's something called a imperative language. Imperative, hopefully I'm not making mistakes, language. Now, this is really important because the goal of us learning Java or any language really is to be able to achieve something, a certain goal, is to be able to do something, display some information, get some information, do something. All right? And these languages are going to allow us to do that by following a sequence of statements that we write. So commands that we write, it will follow it, and it's going to be able to reach that goal that we have. Okay? And these statements are set to change the state of the program as each one is executed in turn. So it's going to go one by one, execute them, and that's going to allow us to reach our goal. And this is what an imperative language means. There are some other languages that do not follow this mindset or this rules. And maybe we'll talk about it, but maybe you'll see it in the future. The point is, this is a key feature that makes it more straightforward to us than something that could be going anywhere, doing anything, etc., etc. Okay, this is why we're going to be using Java. Again, Java is just a language. What's really important is the paradigm that we're trying to learn, in this case, OOP. But the Java syntax, and there's a little bit of a few things that's specific to Java, We need to learn those things because you never know where you're going to land in 3, 4, 5 years. The same way you didn't know you're going to be here 5 years ago. Don't plan the future, which you can't do. So what you want to do is open as many doors, as many possibilities, so that when it shows up to your doorstep, you could open that door and take that opportunity. Okay? So that's it. And now let's get started. See you guys in the next video.